JavaScript is a single-thread language. So what does thread mean? Thread and process are often talked about together. Process means the execution of the entire program. Thread means an entity within a process. One process is made of several threads. You can think of process as driving a car from A to B. Thread is each operation you take to get the car to the destination, like starting the engine, making turns, finding the right route, etc. For the process to succeed, each thread must be successful. Being single-threaded means JavaScript can only handle one task at a time. This does limit its processing power, but the upside is the program development is relatively easier as we do not need to worry about coordinating different threads. To get better performance, JavaScript fakes or simulates the behavior of a multi-thread language. It does so by dividing an entire program into synchronous code and async code. Synchronous codes will be executed in the same order as they are defined. After the first task has been completed, the second one will start. This also means synchronous tasks are blocking. The next task will be blocked by the current one. It won't get executed until the current task has been completed. Async tasks, however, will not be executed right away. They will be skipped and executed later. You will learn more details later. We have 3 console log statements here. These 3 statements are all synchronous codes. If we run the program, the result we get will be 1, 2, and 3. Because the 3 console log statements will be executed in the same order as they are defined. Synchronous codes are also blocking, meaning the current task will block the following task. The following tasks won't be executed until the current one has been completed. We won't get 2 and 3 until 1 has been output. The alert method is also synchronous. Let's put it between the first and second console log statements. Let's try the program. Like we said before, synchronous codes are blocking, so the alert method will block the execution of the second and third console log statement. If we do not click the OK button on the pop-up window, we will only get 1 on the console table. 2 and 3 will never show up. After we have clicked the button, the second and third console log statements will be executed, and we will get 2 and 3 on the console table. In our real-life development, if a synchronous task takes too long to complete, the entire page will freeze. There is no better way to annoy your users than freezing their browser window. This is why JavaScript uses async codes to fake or simulate the behavior of a multi-thread language. JavaScript creates the async effect using callbacks. Codes defined in async callbacks will be skipped first and executed later. This may not be as ideal as a multi-thread language, as different tasks can be executed simultaneously. But this is the best balance we can get without completely rewriting JavaScript. The callback in the setTimeout function is async. Codes defined in it will be skipped first and executed later when synchronous defined behind the setTimeout function have all been executed. Let's move the alert method into the callback of the setTimeout function. Now let's try the program again. This time, we will get 1, 2, and 3 on the console table first. Then the pop-up window will show up. The JS engine will first execute the console log statement on line 4. Then the JS engine will execute the setTimeout function and skip its callback. In the end, the second and third console log statements will be executed. So we will first get 1, 2, and 3 on the console table. Now there are no synchronous codes left. The JS engine will go back to execute the skipped callback. The alert function will be executed. This is why we will get the pop-up window at the very end. Now pay attention here. It is the callback of the setTimeout function that is async. The setTimeout function itself is synchronous. If we console log the setTimeout function, we will get its returned value right away. See? We got 1, which is the timer ID assigned to the setTimeout function. The then, finally, and catch methods are also async. But newing the promise constructor is synchronous because it is nothing different than newing an ordinary built-in constructor. For example, we console log the promise object right after we instantiated the promise constructor. We can see the promise object is output between 1 and 2. Now let's summarize. When the JS engine is executing the program, it will first execute the console log statement on line 4. Then it will new the promise constructor and create a fulfilled promise. Then it will output the promise. So we got 1 and the promise object. The then, catch, and finally methods are async. The JS engine will skip them first and execute synchronous codes defined behind them. So we got 2 and 3 on the console table. Behind the third console log statement on line 18, there is no code left. So the JS engine will go back to execute the skipped codes, which are the then, catch, and finally method. This is why the then, catch, and finally methods are defined before the last 2 console log statements, but their outputs show up at the very end.